So, if you're talking about, has everybody got all this stuff they want? So, if our data is length of bat wings, no idea where that came from. Right, so I go and measure out all these bunch of bat wings, right? So I have categories. What makes sense? You came up with bat wings, Jenna. All right, 2 centimeters to 3 centimeters, 4 centimeters to 5 centimeters, right? Because you got these mammoth bats down there somewhere I don't want to go. All right. This will be the x-axis. The numbers that have to find a place on the x-axis, right? This will be your y-axis. All the count, the frequency, or the relative frequency, if you make it a percentage and I ask for it, will be the y-axis. So if I was talking about age of bats, that would still be going into the categories. Is that all right?
The issue I ran into was because I wasn't hopping like from one number to another, but when I was like working on the homework, it was just one whole number.
Oh, sure. So there was that example on the quiz where it was just, things like this, that problem you're talking about, right?
Yeah.
All right. So the best thing to do is to not copy what the book has, because the book is wrong in this problem. I love how the answer key is wrong sometimes. It'll catch you anyway, but it just makes it easier for those you just copy and shit. The best way to do this is to make that a midpoint. Because otherwise, what would you have to use? What does 3 go from to? 2.5. Yeah, so you can totally do that shit too. 2.5, 3.5, 4.5.
I guess I didn't know that you could use it as a midpoint while drawing.
Yeah, the midpoint makes it easier, but even if you didn't know that, you still do the boundaries.
Got it. Okay.
Yeah.
So are we okay with just labeling the y-axis as like frequency?
Yeah, what are the only labels that would ever show up on a y-axis? Frequency or relative frequency? Or real freak, I like it. So you guys look angry, I'm sorry. Yes. Yes.
It was the last one on 2.4.
Number what? 19?
90.
9. Oh, that was the... Yeah. Where'd it go? There you are. I love this one, and I would. All they give you the data, but they give you counts of it. So how many zeros were there? Yeah, 9 ones. Gotta keep going though. 6, 4, 1. So how many data points am I working with? Don't say 5. Because how many zeros are there? How many zeros are there? 5. So how many data points am I working with? 25. Kick ass. Right? So this one's asking you to make a box plot. What goes into making a box plot? Box plot. It's a long plot. 5 number summary, which is what? I like, there's Q1, there's a Q3, Q2, there's a low. High. They go down, we go high. Alright. Well, how we doing? You alright? Yeah. Okay. I like how you're still shaking. I'm fine. I'm doing great. What's the lowest data point?
1.
0. There were 5 zeros, right? So the lowest data point is 0. What's the highest data point? 4, right? I didn't leave anybody out, no. Right? Yes? So what what gets wrong in your head is you guys don't know how to parse what this shit out. What's the actual list look like if I wanted to write the list? I don't want to do it, right? I mean, screw it. So this is a much better way for them to give me the data. You just have to know how to work with this because you don't have a list. Who gives a shit? How do I find Q1? And you're all like, I give a shit because you said I should do this problem, Jeff. How do I find Q1 always? 25% of what? Yes, there's 25 data points. And what's a quarter of 25? 6.25. And what do you do with 6.25? Round it up. And what's the seventh number? Yeah, the first 5 are 0, 6, 7. The seventh number would be a 1. You could make the list if you want to. I'd hope you wouldn't, because maybe I'd give you a problem. 50, 98, 60. You don't want to make that list, shit. So you should be able to figure out. The first 5 are 0s, 6, 7 is a 1. What's the 15th number? For example. It's a 2. Because what's the first 14? 0s and 1s. The 15th number would be a 2. Do you guys see that? If you can see what I just said, you can do this problem. Because what's the steps on a percentile? Which is what these are, of course, quartiles. Is to find out where the answer is and then go get it. Well, you have to know how to figure out where the shit you are. But it's not that far removed from if they just gave me a list. So what would this be? That would be 1. What about Q2? It would be half of 25, which is, do that one for you. 13. And you know, what's the 13th number? Still a 1, right? I'm not out of the ones. The 14th number is a 1, so the 13th number is still a 1. You guys, is everybody seeing that? So this is what math is. You learn an idea, but you're not going to see it the same way all the damn time because the idea is independent of a way to show you shit. So that's why I'm trying to teach math. What's the idea here? That's what's most important. So then you're not like, I never saw a problem like that. You're like, oh, that's this idea. Beautiful. Yes?
So if you're allowed to have, I guess, like 1, can you repeat it? Can we put,
Yes.
How would it look on the...
Remember, what did I say? The book likes to put a dotted line, which is not a bad idea because it would be a line on top of itself, right?
Yeah, that's what I was...
So this would be, so far, I've got, get out of there, Jeff. There you go, buddy. So far I got low is 0, Q1 is 1, Q2 is also 1, so I like the way the book does it. They make it dotted if it overlaps. And then you're going to figure out Q3, and then your box is supposed to go from Q1 to Q3. Well, Q1 and Q2 are the same, so it's going to go, wherever the shit the other guy goes, it's just going to look like that. All right, that's all I'm going to do for a moment. I'll let you guys finish that. So we talked about the fact that definitely if there's a lot of repeats in your data, the quartiles could be the same. Yes?
Confused about 25 because like they do like is it like the sum of the graph?
How many zeros were there?
5.
Okay, how many total data points were there then? What would you do? If there are 5 zeros, how many ones?
9.
All right, so how many total data points?
Just add them all together.
Add these up, yeah. We know that. If I add the frequency up, I get the total number of things there were. We know that. It's just that this isn't quite in that form that we're used to, and that shouldn't matter because the idea doesn't care what it looks like. And I know as a student, you're like, I care. Just show me exactly what it's going to... No, screw that shit. I like it.
Can we just maybe do an example with finding the variance or something using the equations we're going to use?
Totally. This is a great question. I'm sure other people had this question. Let's do it. Today is all about, if I'm talking about something that you totally understand, you can just work on quiz corrections if you haven't finished those, right? Quiz corrections are due Tuesday. I like it. You can turn it after that if you want less points back, but okay. So let's do an example of finding variance, standard deviation. Yeah. All right, somebody give me a number. 1. Somebody give me a bigger number. 5. Keep going. Give me another one. 10. Don't say 15. It doesn't matter, but 13. I like it. And then one more. 20. 1. Sure. Okay. Crowdsourced numbers. If just looking at this, let me see. It's not exactly evenly distributed around 10, right? But it's not that far off. So if I say I think the mean is around this, let's guess what the standard deviation is going to be. We're going to be wrong, but we should be decently close. How far away from 10 do all the numbers get? Well, that's like 5 and 9 away. That's like 3 and 11 away, right? So if I kind of average all that shit out, maybe it's going to be like 7 or something. I don't know if you guys, because what's the standard deviation supposed to measure?
The average distance from the mean.
The average distance from the mean to all the data points. I love it, right? So my quick guess, if I had 5, 9, 3, 11, and 0, and I said, well, it's probably kind of low for what I said, but I said like 7, 8, somewhere around there. Just averaging those real quick. Okay, because there's no reason to do it for real. This is just getting an estimate. So I'd say roughly 8 or so. It's probably going to be a little bigger than that. All right, do you ever have to do what I just did? No. But it's nice to kind of see that done because that's the idea of what a standard deviation tells you. So if you get a standard deviation of 3, you know you're wrong. Because they get further away from the middle on average than 3. If you get 27, oh holy shit, there ain't no data points that are 27 away from the middle. So that doesn't make sense for an average distance. You guys see what I'm saying? Okay, I like it. Because I really love it when people get negative standard deviations. I'm like, what would that mean? If you're negative feet away from me, you're inside. All right. So let's say this is a sample, because that's pretty much what I'm going to give you is a sample. So I just gave that away. Because that's what we use most of the time in statistics, is a sample. So now you know in the test, if I say find the standard deviation, it's going to be a freaking sample. So you're going to divide by n minus 1. You're going to use that formula. Oh shit, I just gave it all the way out. So what's the first thing I've got to figure out then, before I even put that there? What do I have to figure out first? I heard it. Because the whole idea of a standard deviation is how far away from the mean you get. I got to figure out what the mean is. Okay. So how do I get the mean? I got to first add them all up. Let's see how well we pick numbers. That's actually nice. Holy shit. Right? 34, 44, 50, right? 16, 20. I'm a little, right? Nobody's going to help me. You're all like, you're the math boy. Come on.
Yeah, it's good.
And then to get the mean, x bar is the sum of x over n. 50 divided by 5 is 10. Good job, guys. Holy shit. Nice job. Good job. What's this next column going to be? X minus the mean. To see how far away they are. Because that's the basic idea of standard deviation, is that how far away does each one get? Alright, so then we got a nice whole number here that kicks ass.
1 minus 10.
Good. Which is? Negative 9.
5 minus 10.
Yes?
0.
That is neat. Oh, sorry. 0. That's really geeking out over how randomly picked numbers came up. Sometimes it's neat. And then this would be 3. Hold on, what? Yes?
Could it ever be like a decimal?
Of course. Yeah, because the mean, I'm not going to let you round the mean if it's not a whole number. I'm going to tell you to round it to a certain decimal place so you don't go insane with it. But if you round it too much, does this make sense? If the standard deviation measures how far from the middle I am, and I move the middle, isn't that going to throw my standard deviation off? Yeah. So that's why I don't want to move the middle too much. So if you get 10.4 and you round it to 10, shit, your standard deviation will be way off. Okay. What should all these equal close to in this case exactly, because we didn't round it all? And this is a nice example because is this symmetric? No. They're not evenly spaced, are they? But what are these at? These are negative 14 and these are positive 14. This will always be 0 or close if you add around. That's why we did the next thing we did. What's the next thing we do? Square this shit. I like it. To kill the negatives. Die, negatives. Bang. Negatives messing us up all the time. Negatives and zeros. They always find a way to mess us up. And what formula am I using, by the way? Good. An adjustment because it's just a poor little sample. Like it. So now I've basically got everything I need for that formula. I just have to kind of put it down there for myself. What do I have to do before I can use that? What's the formula I need from me? I need a bunch of those. Do I have a bunch of those? Yeah.
Yes.
Yeah. And then I have to add them up. What do you get? I know what you get. What do you get? Huh? 236, yes. Thank you, person. Become a E thing. It's in the math. Sorry. They're all for me. They're all for me. So, how do I set up this formula up here now? What goes on top? Yeah, the sum of all that shit is 236, yeah? What's n? 5. There's 5 numbers. So what do I divide by? 4. And 4 goes into that shit evenly. That's crazy. This problem is insane. It's actually a little bad that we're not getting ugly decimals, but oh well. Huh? I should do this on the test? Alright, I won't. Gotta use psychology, reverse psychology on me. It's too late. It's too late. Huh? We good? We good? So what do we get there? That's 59. So what's the standard deviation? It's actually smaller than my guess, isn't it? How do you get it? What do you do? Square root. That's gonna be a little less than 8. Right? The square root of 64 would be 8. Square root of 59 is 7.661. Is anybody else playing along? No? I have calculators up here. The apocalypse, you guys didn't get them. I want to try to cram as much stats in your head before we all die. No, yes, no. All right. So, that's kind of nice. It's, I know I guessed this 8, but you guys hopefully follow a little bit. Do you have to ever do what we did here? No, but that's about what we thought it should be. Now, I want to show you, if you will want a calculator now, and we need to borrow one, you don't have to, but I'm going to show you something neat. How to make the calculator do this work for us. Make sure it's got, everybody's phone, make sure it's got battery before you get too far away. Take a minute, go into your lists, and just take a minute, clear them all out. If you forgot how to do that, ask somebody near you. If nobody knows how to do it, I'm just going to leave. catch up to you. No, I don't want to. Yes, you will. What is that? Ooh, that's neat. I used to be here. Catch up to you guys. Oh. There we go. We can clear this out. Clear. You can also go stat. Clear list. It's not any quicker, really. L2, comma, L3. Yay. Stat. That's why you have punctuation on your calculator. Little comma. By the way, you guys know this. If you hit the second button and then up, it makes it brighter, and the second button and down, it gets darker. Second button up, brighter. Second button down, darker. It's kind of like an early warning for your battery if you have one that you can't see the battery indicator. If you have to make it brighter and brighter and brighter, the battery's slowly going away. What's the matter?
Not on this one.
What? What not on that one? Okay. Terrible. What's terrible? It's terrible. State of things is terrible. Alright. So let's see what we got. 1, 5, 10, 13, 21. So I'm not gonna. Did I put that in there right? I'm not gonna show you again how to get these. Alright, this is L2, L3. L2 is L1 minus the mean. Does anybody want me to show you that again real quick? I will if you want me to. No, okay, all right. What I want to show you, hit stat. Oh, I love this question. How many variables are up here? And you're all, I ain't gonna say shit because I can tell I'm gonna get that damn thing wrong. How many variables are up there? Come on.
15.
No. No.
Was it the end?
There's one variable with how many values? 5. So now watch this. I want to count. Yes.
Isn't n also like a variable?
X is the only variable up here, and then I did shit with it. Yep. If I had a Y column that represented, like this was the number of, what would it be, Jeff? I don't know. The number, not number of kids. Holy crap. Anyway, this would be like the number of hot dogs somebody ate. And Y would be the number of antacid pills they took, right? So I'd have 2 sets of data. I'd have 2 variables then, right? Up here I just have 1 variable with this many values. Why am I getting into this? I want to calculate something, correct? I want to make the calculator calculate the standard deviation for me. So I want to go over where it says calc. And which one, based on everything I just said, do I want to do? 1 var stats. I want to do 1 variable statistics. Now, you ready for this? Let's see what it tells me. Oh, yeah. If you have the newer one, it's going to say blah, blah, blah. If you have the older calculator, this doesn't show up. It just defaults to list 1. So if you have, I think most of you guys got this one. List 1. There's no freaky list. Calculate. And look at all the shit it tells you. Oh, baby. So it's going to use this. Because so if I had a population, it's going to use this symbol no matter what, because it's a dumb calculator. We're the humans. But in this case, it was a sample. So there's my x bar, right? There's the sum of x. There's the sum of x squared. Why does it give me both of these? What's this one? Sample standard deviation. Population standard deviation. Why does it give me both? It doesn't know exactly. It's just a freaking stupid calculator. It's not smart. It's dumb as shit. So it gives me both, and we're the humans. We have to pick the right one. So later this semester, it'll be very important which one of these we know. And you can't go, well, I know this one because it told me. If it's a sample, you don't know this. You only know this. So 7.681. 7.681, yeah. So if you are the kind of person that's like, well, why do I do all that shit? It tells me, then you should just keep quiet, because that's learning. And this is not, right? But this is a nice way to check your work, right? You can check your work. Great. Okay, maybe. Scroll down. See how there's more stuff down there? What's the last 5 things it has? No? What's 5 of them are separate for making a box plot. Boxplot. All right. What it can do for you. Read your manuals, kids. If you don't have one, yes you do. The internet's, my God. You got every manual ever made for anything. All right. So what's next? What do you guys want to do? Yes.
Can you go over finding the cumulative relative frequency?
Sure.
And then you said the book does it a different way, right?
No. The book does a few things a different way, but not the cumulative. So let's say we already have like frequencies and relative frequencies, blah, blah, blah. This is like 11%, 2%, 18%, whatever, right? Is that cool? So you've already done all this work. How do I start off my cumulative frequency? Yeah. As I move down, what do I have so far? Now I move down again, and what do I have so far? Move down again, and what do I have so far? Right? And just keep adding. So what should the last entry in this be? 100 or close to it. 95 is not close to 100. That means you did a mistake. I like the way I said it. You did a mistake. I did a mistake. Yes.
Can you go over interval and ratio data?
Sure. Is everybody cool with that?
Yes.
Okay. I think I told you guys, by the way, now that we talked about all that, I don't really care too much about that, so I normally don't ask you that question. But you do have to move to the rest. Make classes and frequency and all that frequency. So then we got nominal ordinal interval ratio. So there's a problem where I'm like, 11% of the kids like green beans, and 3% of the kids like peas, 70% of the kids like ice cream, right? So, what's the data in what I just said? What question would I have asked to be able to get to that point?
What do the kids like?
Yes, I have a bunch of kids. What do you like from that list? Ice cream. Me too, kid. What do you like? I like green beans over ice cream. Yeah. All right. Right? So what am I going to get as a list? That's my data. If I'm asking people, what do you like? What am I going to list? Green beans. Ice cream. And what kind of data is that? Nominal. Nominal is name data. I love the people that say, well, it's a number, so it's nominal. Nominal is the least numerical one. It's name data. Yes?
Once they start saying like how many people chose like ice cream.
Okay, and that's why I let you explain yourself. So if you would have said, what would your answer be then?
For that case, if you were asking how many, I would say it's qualitative or quantitative.
Better than that, nominal, ordinal, interval ratio. Which one? And you're all like, why put me in the spot, dude?
Interval.
All right, so let's talk about that. So if instead of that it was the number of kids who liked something, how many guys like ice cream? And then you raise your hand. I want to see someone raise their hand. But there you go. Right? You guys with me? Then your data would look like what? So I go in one room, how many guys like ice cream? And then go in another room, how many guys like ice cream? I get a bunch of what's? Numbers of kids. Which two could it be?
Interval or ratio?
Because that's true numbers, right? Okay, so now I can distinguish between these two. What's supposed to happen here? No. Subtraction's supposed to make sense. So if I had 11 kids in this room and 3 kids over there, 11 minus 3 is 8. There's 8 more kids here that like ice cream, right?
So like, how would you know exactly which one to choose? Could it
The
be
highest level. So I'm not done yet. I know it's at least interval. What's true about ratio? Two things.
Division has to make sense.
0 makes sense and division makes sense. Well, the easiest thing always is does 0 make sense? If I wrote 0, what does that mean?
0 kids.
There were no kids, so 0 means what it's supposed to mean. So why is temperature, like Fahrenheit temperature, not ratio? What does 0 mean? Does that mean the absence of heat?
No.
No. So it doesn't mean what it's supposed to, the absence of that. That's what 0 is supposed to mean. Now, if you want to explain it from division, if one room had 12 kids that like ice cream, and the other room has 24 kids that like ice cream, 24 divided by 12 is 2. And does that 2 make physical sense? Yeah, there's twice as many kids in that room that like ice cream.
So technically you could put either one, but depending on how you
No. Highest one is the answer. Everything that's ratio is also all of this shit. Oh, that's the room that had 20, that's the 24 room with the 24 kids. It's the name of the room. Right? If you got, I don't know, if you owned 10 cars, you're that 10 car dude. They call you 10, it could be your name. So it's nominal. It's definitely ordinal. There's an order to it. 8 kids, 9 kids, 10 kids like ice cream. Yay. And then it's definitely interval, like I just said. You can subtract the number of kids. Well, what's the most you can do with it? Divide. It makes sense. Your answer is always the highest.
So basically, like all types of counting is usually ratio.
Yeah, ratio is most measurements. Temperature scale is funky because it's a measurement scale where we didn't put 0 where it was supposed to be. It's only Kelvin, the one that some of us have heard of, that puts 0, and 0 in Kelvin means we're all dead because there's no energy. So we don't want to be there. Yeah, okay. Unless you're doing really cool experiments and weird shit happens close to 0. Sorry. You've all seen like the super cool, some guys have seen like the magnet floating over the other thing. It looks really cold. Have you ever seen that? It's the properties of certain metals at really cold temperatures. I'll shut up. I'm sorry. It's just the research I was doing for my PhD that I didn't quite get to. Things happen. Yes?
Could we just go over discrete or continuous data?
Oh, good. Yes. Is that something I kind of left for you guys to do in your homework? Continuous is the easier one to start with. The name kind of tells you what's happening. It's a variable where the answer it's a kind of data. It's the kind of answer to a variable that where it could have any value between two things. So anything in a continuum. So for example, if I ask you how many kids did you grow up with? How many siblings?